So NumPy deals with NDArrays. NDArrays stands for n-dimensional arrays. And n, of course, means that these arrays can be any dimension. So let's think about these concept of dimension and arrays. And let's start with the simplest array or the simplest construct you can imagine, a scalar. A scalar is literally just one value, one number, as we've seen in basic Python. So 1, 2, or 3.5, all of these would be scalar. Then the next construct in the list is a vector matrix or a vector. A vector is a one-dimensional array, so you can have a series of number and that's your vector. Then comes a 2D array. A 2D array is known as a matrix. And 2D arrays are used a lot in computing because there's a lot of very efficient matrix operation that you can perform. So it's a very, very efficient construct. So matrix are extremely useful. If you go higher than a matrix, then you start to look at NDArrays or multidimensional arrays, and these are known as tensor. So you might think that a tensor can be a 3D tensor, for instance, and you're right, 3D tensors are absolutely natural where you would have three-dimensional data. But you can of course go to tensors of higher dimension. For instance, you can have a 4D tensor, and that's harder for us humans to really get a representation of what a 4D tensor is, or a tensor of dimension 4. But really, you're very familiar with tensors of dimension 4 because you're looking at one right now. This very video you're watching can effectively be constructed or represented programmatically as a 4D tensor. Why? Well, the image is 2D. You have X pixel and Y pixels. But what you may not know is that the image being in color, it comes with 3 layers, RGB. Red, green, and blue are separated. So really the image information itself, the static image, is already a tensor of dimension 3 because you have the 2 dimension plus the fact that you have separate channels for the different colors, RGB. And then, of course, because it's a video, you have a 4th dimension, which is time, because not only do you have a 3D static image, but this static image is piled up in the 4th dimension, which is the dimension of time. So having a good understanding of tensor and these different constructs like scalar, column vector or matrix vector and matrices is very important for data science. So let's look at how we can actually create this construct in NumPy. If I want to create an array from a Python list, it's fairly simple. So let's first create a Python list. And now from this list, I can create an array. And so I've created a 1D list. Now I can actually look at the dimension of this particular array, and it tells me that this is a 1D array. So let's try to create a 2-dimensional list, and from that list in Python, create a 2-dimensional array. Same principle now, I can just use the array method on NP to create my 2-dimensional array. And now let's check the number of dimensions of this particular array, and indeed we obtain 2 dimensions. We can also look at the shape of a particular array. So let's look at the shape of that 2D array. So we can see that the shape method returns a tuple with 2 dimensions, and that's essentially the size of the array. So we see that this particular array has two dimensions. That's the first number here. But also that each one of these 2 dimensions has 4 elements in it, and that's the shape of the array. But of course, the power of NumPy does not stop at creating an array. You can then use this array for all sorts of operations. We've already seen that we can multiply an array by a scalar. In this case, it was 2. But of course, you can also use array in an operation. So let's look at some examples of that. What happens, for instance, if we use 2 arrays for a calculation? So we have this 2D array here that we've created before. Let's try to subtract the 2D array from itself. Can you guess what the result will be? If you said an array of dimension 2 with each one of the dimension having 4 elements, each being 0, you would have been correct, because effectively what this operation has done is that it has automatically subtracted each number from itself. We can also, of course, also do math with a scalar. So for instance, if I want to multiply this array by 2, what I see is that the scalar is propagated to each element in the array. That means that every single element in the array is multiplied by 2. And a division would be exactly the same result. Now we see that we have effectively the inverse of each of the numbers contained into that array. Of course, in the example I showed you, I only used a very simple array. But now imagine that you have millions of numbers in that array. The ability to do batch processing, batch computation is truly the strength of NumPy. And this is why NumPy is used so much in machine learning, data science. It's because we need to do efficient matrix calculation, efficient array calculation. And so this is one of the backbones of the tool shed, if you want, of the data scientist.